Hi everyone. Today I'm going to be talking about the power rule for exponents. So, what do I mean by the power rule for exponents? Well, say I have x squared and I want to raise that entire thing to the second power. Well, this is the same thing as x squared times x squared 2 times. And we know that from our laws of exponents that whenever we are multiplying exponents with the same base, we keep our base and we add the exponents. In this case, we get x to the 2 plus 2, and we get x to the fourth power. And so today, we're going to be doing these types of problems. And so on the left here, we have s to the fourth raised to the third power. Now, keep in mind, what does this really mean? This means s to the fourth times s to the fourth times s to the fourth 3 times. And we know from our laws of exponents that whenever we are multiplying exponents with the same base, we keep our base and we add all the exponents. In this case, we get s to the 4 plus 4 plus 4, and we get s to the 12th. Alternatively, another way to think about this is that you can multiply the 3 and the 4 together, and you would get s to the 4 times 3. And that would also give you s to the 12th. Okay? Here's another problem. This time we have z to the fourth raised to the fifth power. Again, let's think about what this means. This means z to the fourth times z to the fourth times z to the fourth 5 times. Now, recall our laws of exponents. Whenever we are multiplying exponents with the same base, in this case z, we keep our base and we add all the exponents. So in this case, we get z to the 4 plus 4 plus 4 plus 4 plus 4. And that gives us z to the 20th. Again, you can just multiply out these exponents and think of it as z to the 4 times 5. And that gives us z to the 20th. Okay. Here's another problem. This time we have u to the negative 8th, everything raised to the negative 6th power. Now, it doesn't make sense for us to multiply things a negative number of times. But if you've been following the pattern, the shortcut is we just multiply the two numbers together. So in our case, we would get u to the negative 8th power multiply to the negative 6. Negative 8 times negative 6 is positive 48. So we get u to the positive 48th power. Okay. Here's another problem. This time we have w to the 6th, everything raised to the negative 7th power. Again, we would just multiply these two numbers together. W to the 6th times negative 7th. 6 times 7 is w to the negative 42th power. Okay? And if we wanted to convert this with using only positive exponents, we would just make it positive and push it down to the denominator. This would be 1 over w to the 42th power. However, if you read the question, they don't ask us to express it as a positive exponent. So what we have, w to the negative 42 power would be just fine. Here's another problem. This time we have h to the fifth power j to the 0th power, everything raised to the 10th power. Now, notice here we have two variables to the power instead of one. Well, the idea is pretty much the same. You would just distribute and multiply the exponent to each of the exponents that you see. So here you would do h to the 5 times 10 times j to the 0 times 10. Okay, so it's kind of like, I like to think of it as like distributing. This 10 gets distributed to the 5, and this 10 gets distributed to the 0 here. Okay, and then we're left with h to the 5 times 10 is h to the 50th. And then j to the 0 times 10, well, anything times 0 is just 0. Okay, and we know that anything to the 0th power is just 1. So this is really h to the 50th times 1, which is just h to the 50th. Okay. Let's do one more problem. Here we have j to the negative 12th, k to the negative 11th, everything raised to the negative 3rd power. Again, we're going to be thinking about distributing our powers here. So we're going to distribute the negative 3 to the j's exponent and the negative 3 to the k's exponent. So here we have j to the negative 12 times negative 3. And then we have k to the negative 11th times negative 3. Okay. Negative 12 times negative 3 is positive 36. And negative 11 times negative 3 is positive 33. And that is our final answer.